Imagine you're sorting through data and need a razor-sharp tool to draw the perfect line between categories. That's where support vector machines come in, a machine learning powerhouse built to make decisions with precision. Today, we're coding SVMs live, visualizing how they classify data, and unlocking their full potential in solving real-world problems. Let's get started. Here, we're importing essential libraries: Pandas for handling data, NumPy for numerical computations, Matplotlib for visualizing data, and Seaborn for creating clean, detailed plots. We load the iris dataset with readd CSV, preview it using df.head, and get quick stats with df.describe. We use df.n unique to see the number of unique values in each column, and df. is na.sum to check for any missing values. This pair plot visualizes relationships between features, with color coding for each species. Here we're creating a series of violin plots to visualize the distribution of each feature. Sepal length, sepal width, petal length, and petal width across the different species. These plots combine aspects of box plots and kernel density plots, showing the data's range, median, and distribution. This box plot displays feature distributions, including medians, quartiles, and outliers. Let's replace the species names with numbers. One for Iris setosa, 2 for Iris versicolor, and 3 for Iris virginica. Here we're splitting the dataset into 3 parts: df1 for Iris setosa, df2 for Iris versicolor, and df3 for Iris virginica. Now we're creating 2 scatter plots to visualize the relationship between sepal length and sepal width for each species. In the first plot, we compare Iris setosa and Iris versicolor. And in the second plot, we compare Iris setosa and Iris virginica. Here, we're separating the features from the target variable. X contains all the features except species. And Y holds the target variable, which is the species. Now we're splitting the data into training and testing sets, with 80% for training and 20% for testing. Now we're importing the support vector classifier and creating a model instance, ready to be trained on our data. Next, we're training the model using the training data with model.fit. Then, we evaluate its performance on the test set using model.score, which gives us the accuracy of the model. And that's how we can implement and evaluate a support vector machine on the Iris dataset. If you enjoyed this, stay tuned for the next video, where we'll dive into another popular algorithm, k-nearest neighbors, KNN. We'll compare it to SVM and explore when to use each.